So parameter, to introduce parameter, let me tell you what I thought about parameter first. When I first learned about parameter, I didn't know that it was different than the word perimeter. So we're the same, okay? We're the same, all right? So if you think that it's perimeter, well, it's not. This is parameter. Now, if you study computer science, then you may know parameter. If you do engineering, then you will know parameter. So in short, you can think about parameter as a constraint, as a condition, okay? Now, if you took physics or if you are currently taking physics, okay, then you should know about this parameter very well without knowing that it's called parameter. If you think about projectile motion, okay, if you think about projectile motion, remember how you did all the calculations with projectile motion? The first thing that we need to do is that we give you a velocity. We give you a velocity, let's just say this is 10 meters per second. And we also tell you that the angle right here, it's 35 degrees. The very first thing that you do is to split this velocity into two components, the x and y, the x component and the y component, so that you can compute the distances individually. You apply the acceleration individually because there's only acceleration for the vertical component, not the horizontal one. So, and ultimately, how far would it travel? We always ask that question. How far would it travel to the right? And we say, oh, you only travel, well, that depends on the time. If the object spends longer time in the air, then it's going to reach farther. And that's how you know if it is going to reach a certain distance. So what I want you to see here is that you have seen parametric equation before, you just didn't know that it's parametric equation. So consider that, okay? We have two equations. Okay, you have an x equation, you have a y equation, and they both have, they're both expressed in terms of t. So in order to know where the object is, okay, you can consider t as time. So what you can do is this. You can go ahead, make a table. You have t, x, and y. And then you can go ahead and say t is equal to negative 2, negative 1, 0, 1, and 2. And so we say, well, if t is equal to these values, then what about the x value and y value? No, just plug in and find out. So when t is equal to negative 2, x is equal to negative 5. And then y would be 3. Okay. And when t is equal to negative 1, x equals to negative 3, and y is equal to 2. And when t is equal to 0, then x equals to negative 1, and y is equal to 1. And then when t is equal to 1, x equals to 1, and y equals to 0. And for t equals to 2, x equals to 3, and y equals to negative 1. Now, if you are very sensitive to numbers, you may see something quite special with the x. You can see that the change of x is always minus 2, while the change of y, it's always, no, the change of x is always plus 2. The change of y is minus 1. Okay, now, so let's go ahead and plot these points. Okay, let's go ahead and plot these points over here in the graphing area. So you have negative 5, comma 3. We have negative 5, comma 3 right here, right? Now, to indicate that, well, if you just plot a point right there, you presented the x value, you presented the y value, but you're not presenting a t value. So we have to write it down. We'll say t equals to -2. Okay, so that people can tell that, oh, so at time equals to -2, that's where the object is located. And then the next value will be -3, 2. So you'll be right here. So t equals to -1. And then you have -1, 0 when t is equal to 0. And then you have 1, 0 when t is equal to 1. And then you have t equals to 2 when x is 3 and y it's -1. And based on all these points, what kind of path do you see? Or what kind of function do you see? Linear, right? So now, so this is the way we will do the linear function, okay, or linear line. So we'll draw it this way. Now, but that's more because we have a time. It's so you can think about this as like a time-lapse video to show you the position of the particle. So along the line, you got to show the arrow, and the arrow should go in a single direction. Okay, unlike what we did in the past. In the past, we have this linear line. We'll put arrowheads on both ends of the linear line. But for this one, we will go in one direction to show that this is how the particle or this object will progress, okay, as time goes. Okay, so to introduce parametric equations, very simple. Again, it's just that there's a little constraint. It's called time. So we need to look at a time in order to tell the x and y value. And once we do have the x and y values, then we plot the points. And the way we plot the points is that we plot it the usual way, and then next to it we annotate the parameter, in this case time. Okay.